Welcome back to Stack Lessons. In this lesson we're tackling the Mosaic AI Agent Framework, production-ready chains and agents on Databricks, one of the trickier topics on the exam. Let's break it down. By the end of this video, you'll know exactly which Databricks primitives to reach for when you build a production agent, and why hand-rolled LangChain code across 3 repos is a maintenance liability. We'll walk through the canonical chain shape, the recommended agent base class, and the supervisor pattern that combines structured and unstructured data sources. Back in episode 3, we picked the foundation models, embedding endpoints, and ChatDatabricks compatible serving endpoints DataDino's chatbot uses. Then in episode 8, we configured the Mosaic AI vector search index that holds the fossil chunks governed inside Unity Catalog. Today, we're going to wire those pieces into a single production agent using the framework Databricks actually recommends. 5 terms anchor this episode. The databricks-langchain package is the official, supported integration, the one you should import from. ChatDatabricks is the single class that talks to any model-serving endpoint. UCFunctionToolkit turns Unity Catalog functions into governed agent tools. ResponsesAgent is the recommended base class for new agents, and a Genie Space is the text-to-SQL interface over your structured Unity Catalog tables. We'll see each of these in action. DataDino's first fossil retrieval augmented generation, or RAG, chain worked. It also lived in 3 different GitHub repos. The auth wiring lived in one repo, the retriever calls were in another, and the prompt templates were scattered in a third. One senior engineer held the whole map in their head. When they left the company, nobody else could debug it, version it, or safely deploy it. That's the story behind why Databricks built the agent framework, and why we're spending a whole episode on it. Here's the mental model shift to make before we go further. You don't need to memorize the entire LangChain class hierarchy. What you actually need to know is the small set of Databricks integrated primitives, the recommended agent base class, and how tracing wires everything together. That's the production stack, and that's the lens for this video. Here's the contrast that drives everything else. On the left, hand-rolled LangChain, every notebook rewires auth, every agent invents its own request and response schema, and tracing only exists if someone bothered to add it. Tools end up as loose Python functions scattered across notebooks, and only the original author understands the topology. On the right, the agent framework, auth comes from the primitives, the schema is auto-inferred from your base class, tracing is built in, and tools become governed Unity Catalog objects. Any engineer can open a trace and read it. Think of the primitives as a kitchen that came pre-plumbed. ChatDatabricks is the stove socket, wired and to code. DatabricksVectorSearch is the waterline, already connected to your governed indexes. UCFunctionToolkit is the dedicated outlet for the dishwasher, with the breaker already labeled. You're not running your own gas line in the walls anymore. 4 primitives, all from the same package. ChatDatabricks is the one chat model class that targets any model-serving endpoint, a foundation model API, a custom MLflow model, or an external model proxied through Unity AI Gateway. Databricks Embeddings is the embedding client, with the same auth and governance as the rest. DatabricksVectorSearch wraps a Unity Catalog vector index, call as retriever on it, and you get back a LangChain retriever, with maximal marginal relevance, or MMR, and metadata filtering supported. And UCFunctionToolkit exposes Unity Catalog functions as agent tools, with permissions, lineage, and tracing already attached. One quick warning before we keep going. The supported package is databricks-langchain. That's the one you want. There's an older package called LangChain Databricks, with the words reversed, that quietly stopped receiving feature updates. Production agents still importing from the old one are why teams suddenly find features missing. Use the new name. Let's talk about why ChatDatabricks is the workhorse. The same class talks to custom MLflow models you've registered yourself. It also talks to external models like OpenAI or Anthropic when they're proxied through Unity AI Gateway, and the same class targets foundation model API endpoints, Llama, Claude, Mixtral, without changing any code. The practical consequence is huge. Swapping your large language model in production becomes a one-line endpoint change. No new SDK, no new auth, no rewritten chain. This is the canonical retrieval chain shape, and it's worth recognizing on site. You wrap DataDino's fossil chunks index with DatabricksVectorSearch, then call as retriever to get a LangChain retriever returning the top 5 matches. You build a prompt template with 2 placeholders, context and question. ChatDatabricks points at the Llama 3.370 billion instruct endpoint, and the chain composes them with the pipe operator, a dictionary that prepares the prompt variables, then the prompt, then the model, then a string output parser that flattens the answer. The format docs helper is a small lambda that joins retrieved chunks into one string. That left-to-right flow is the pattern. Read the pipe left to right. Step 1 is the dictionary that prepares prompt variables, the retriever fills context, the pass-through forwards the question. Step 2 is the prompt template, which fills its named placeholders. Step 3 is the model, ChatDatabricks, which produces a chat message answer. Step 4 is the string output parser, which flattens that message into plain text. The 2 failure modes you should watch for: missing the prompt entirely, or placing the parser before the model. Both produce code that looks superficially right but won't run. Here's the payoff for using ChatDatabricks. You started on Llama. Your team wants to A/B test against Claude. You change one string, the endpoint name, the chain definition, the retrievers, the tools, the tracing, nothing else moves. That's the difference between a primitive that abstracts the endpoint and a hand-rolled client that bakes the provider into every call site. Quick checkpoint: we've covered the 4 primitives and the canonical chain shape they compose into. Next up is the wrapper that turns a runnable chain into a deployable, traced agent. After that, we'll look at where AI Playground, Genie Spaces, and the multi-agent pattern fit into the picture. Here's the distinction worth pinning down. A chain runs, you call invoke and you get a string back. An agent runs, traces, registers itself to Unity Catalog, supports evaluation, and serves through model serving. The agent framework is the wrapper that adds those last 4 capabilities on top of your chain. There are 2 base classes you'll see in the docs. ChatAgent speaks the older chat completion message format. It's framework agnostic, signatures get auto-inferred, and it's still acceptable for existing agents. ResponsesAgent is the newer surface, and it's the current canonical base class on Databricks. It supports annotations and custom inputs and custom outputs, and it requires Pydantic version 2 or higher. It's wire compatible with the OpenAI Responses API, and it returns the richer ResponsesAgent response and stream event types. For anything new, ResponsesAgent is the answer. Think of it as USB-A versus USB-C. ChatAgent does the job, it's universal, it works, but it's the older shape. ResponsesAgent does the same job with more power, annotations, custom payloads, streaming events, and it's forward compatible with the spec the rest of the industry is converging on. Straight from the Databricks docs, they recommend ResponsesAgent for building agents, and they call out specifically that it lets you bring any third-party framework, LangChain, LangGraph, your own code, and then plug into the Databricks features for logging, tracing, evaluation, deployment, and monitoring. That's the contract. You bring the agent logic, the base class brings the platform integration. The deprecation arc, in 3 steps. Chat model was the original, and it's legacy now, so don't use it for new agents. ChatAgent came next, still acceptable, but superseded by ResponsesAgent, which is where all new work lands today. If you remember one thing from this slide, Remember that order. Here's the smallest useful responses agent for DataDino's fossil chatbot. Use subclass responses agent and implement predict. The decorator above predict, MLflow.trace with span type agent, is what creates the top-level agent span in your trace. Inside, you call your chain's invoke method with the last user message, and you return a response built with the base class helper. That's the whole skeleton. The chain we wrote earlier slots in unchanged. What does that one decorator actually buy you? The decorator creates the top-level agent span, the parent for everything else. If you wrap your retriever with vector search retriever tool, retriever calls automatically emit retriever-typed spans. If your tools come from UCFunctionToolkit, every tool call shows up as its own tool call span. That means when something goes wrong, you open the trace and read it, instead of guessing which retrieval or which tool misfired. So when a fossil chatbot answer comes back wrong, you don't argue about it, the trace already tells you exactly where the failure happened. Tracing is the agent's flight data recorder. When something goes wrong in a multi-step agent, a retrieval returned the wrong chunks, a tool timed out, the model hallucinated despite good context, you don't reconstruct the failure from logs and memory, you replay the recording. And here's why you should not be writing your own request and response schemas. When you subclass responses agent, MLflow automatically infers a signature that's compatible with the rest of the Databricks platform, AI Playground recognizes it, Agent Evaluation recognizes it, Model Serving recognizes it. Hand-rolled schemas are how you accidentally lock yourself out of features you'd otherwise get for free. Remember DataDino's check license function from episode 4? Here's how it becomes an agent tool. You instantiate UCFunctionToolkit pointing at the fully qualified Unity catalog function name. The toolkit.tools property gives you a list of LangChain tools, already traced, already permissioned through Unity catalog grants. You bind those tools to ChatDatabricks, and the model can now call check license as part of its tool calling loop. No loose Python functions scattered across notebooks, and every call is auditable. AI Playground gets dismissed as a toy by people who haven't used it. The docs are pretty clear about what it actually is. It's a chat-like environment for testing prompts and comparing language models side by side, and critically, it's where you prototype a generative AI app with tool calling agents and question answering bots before you write a single line of chain code. Here's the workflow that turns Playground into the design surface. Step 1. You chat in Playground, compare models, tune temperature, tune max tokens, find a prompt that works. Step 2. You attach Unity catalog tools and try them interactively, so you can see whether the model actually calls them at the right time. Step 3. You click Get Code, then create Agent Notebook, and Playground exports a responses agent scaffold. Step 4. The exported notebook already wires Unity catalog registration and model serving deployment. You fill in evaluation and you ship. One important caveat that Databricks calls out explicitly: the exported notebook may behave differently from your Playground session. The prompts, the tool wiring, and the underlying defaults can drift between the two surfaces. Treat the export as a head start, not a final artifact. Iterate, evaluate, and only then deploy. Now let's pivot to Genie, because it plays a specific role in multi-agent systems. A Genie space is a domain-scoped, text-to-SQL interface over structured Unity catalog tables. Data stewards curate the tables, write descriptions, add synonyms, and define benchmark questions. The quality is dominated by that curation. Out of the box, Genie is mediocre, but a well-curated space handles non-trivial cross-table questions remarkably well. The key boundary: Genie only handles structured data, not PDFs, not volumes, not vector indexes. The split between Genie and ARAG agent is the single most useful mental model in the multi-agent section. Genie sits on structured Unity catalog tables, runs text to SQL underneath, and returns rows plus the generated query so you can audit it. Quality scales with how well the stewards curated the space. RAG Agent is different. Its quality scales with your chunking and re-ranking choices. It sits on unstructured documents in volumes, runs vector or hybrid retrieval underneath, and returns grounded natural language answers. They are not interchangeable. Genie also exposes a programmatic surface, the Conversation API. It's a stateful REST endpoint, where you post to start conversation against a space ID, and the API retains context so you can ask follow-up questions inside the same conversation. Every response includes both the tabular result and the SQL Genie generated, which is exactly what you want for auditability. And as documented by Databricks, it's rate limited. Check the current docs for exact thresholds, but expect a small number of requests per minute per workspace. The Genie Conversation API is rate limited to roughly 5 scenarios per minute per workspace. If you put Genie inside a tight loop, say 1 call per row of a data frame, you will hit that ceiling almost immediately and your agent will start failing. The engineering rule is straightforward: batch related questions into a single Genie call, and cache results aggressively so repeat questions never go back over the wire. That same constraint is worth remembering for scenario questions about scaling Genie-backed agents. Here's the bridge. The Genie Conversation API is plugged directly into the Mosaic AI Agent Framework through the databricks-langchain.genie wrapper. That wrapper exposes a Genie space as something called a Genie agent, a first-class agent your supervisor can treat as one more tool in the toolbox, right alongside your RAG agents and your UC function tools. Here's the architecture viewers should picture for a real enterprise question. A user asks something that spans both kinds of data, say, why first quarter revenue is down and what customers are complaining about. The question hits a supervisor agent, which routes by question type. The structured piece, what was Q1 revenue, goes to a Genie agent over the curated sales tables. The unstructured piece, what are customers saying, goes to RAG responses agent over support ticket documents. Both come back, and the supervisor merges them into one grounded response. If you remember one picture for the multi-agent pattern, make it this one. Genie is the accountant who can read every spreadsheet in the building. The RAG agent is the librarian who has read every document on the shelves, and the supervisor is the executive assistant who knows which one to ask, depending on what was actually being asked. Let's talk about why the exam structure changed. The March 2026 exam guide demoted standalone code a chain in LangChain objectives. Application development is now the heaviest section at 30%. The agent framework, MLflow 3 tracing, and the prompt registry sit at the center of that section. Chain shape recognition is still tested. You'll still see LCEL code snippets, but they show up inside broader agent framework scenarios, not as standalone trivia. So what does that mean for your study time? Spend it on the Databricks-langchain primitives, the ResponsesAgent predict signature, the MLflow tracing decorators and span types, the toolkit classes for exposing tools, and the Genie Conversation API, including its rate limits. Don't spend it memorizing every output parser variant, raw LangChain class hierarchies, chat model migration history, or the deprecated LangChain Databricks package. The platform-specific stack is what's tested. 6 decision rules to carry with you. And here's the one that comes before all the others. Before you write a single line of chain code, prototype in AI Playground and export. Now the routing rules. If the data is structured and lives in Unity catalog tables, use a Genie space and wrap it as a Genie agent for multi-agent systems. If the data is unstructured documents, use a RAG chain inside a ResponsesAgent. For any new production agent, subclass MLflow.pyfunc.ResponsesAgent. For any new tool, write a Unity catalog function and expose it through UCFunctionToolkit. And when you need a chain primitive, Import from databricks-langchain, never the deprecated reversed name package. 5 things to leave with. The agent framework exists to replace hand-rolled LangChain scattered across repos with governed, traced primitives. The trace decorator with span type agent is what turns the agent into a recordable black box. The DatabricksLangchain package gives you ChatDatabricks, DatabricksVectorSearch, Databricks embeddings, and UCFunctionToolkit. ResponsesAgent is the recommended base class, and MLflow auto infers the signature for you. And the data routing rule is simple: Genie for structured tables, RAG for documents, and a supervisor to combine them into one multi-agent system. Now let's see how well you absorbed all of this with a quick 5-question quiz. Question 1. A team is building a new production agent on Databricks that will answer questions over fossil documents using vector search and a Unity catalog function tool. Which MLflow base class should they subclass for the agent? Is it A, MLflow.pyfunc.ResponsesAgent, B, MLflow.pyfunc.chatModel, C, MLflow.pyfunc.chatAgent, or D, langchain.agents.agentExecutor? Take a moment to think about it. The answer is A, ResponsesAgent. Databricks explicitly recommends it for new agents. MLflow Auto infers a compatible signature, so Playground, Agent Evaluation, and Model Serving all recognize the agent automatically. Chat Model is legacy and ChatAgent has been superseded. Question 2. A developer wants to expose a governed Unity catalog function as an agent tool, so that every invocation is auto-traced and permissions are enforced through UC grants. Which approach is correct? A. Import the function with a plain Python import and pass it to the agent as a callable. B. Use UCFunctionToolkit with function names referencing the fully qualified UC function, then pass .tools to the agent. C. Re-implement the function as a LangChain-based tool subclass inside the agent notebook. Or D. Define a REST endpoint with Databricks apps and have the agent call it via requests.post. Pause and think it through. The answer is B, UCFunctionToolkit. It's the canonical bridge between Unity catalog functions and agent tools. Permissions flow through UC grants, tool calls automatically emit spans in MLflow traces, and lineage is preserved. The plain Python import path skips governance and tracing entirely. Question 3. An enterprise GenAI application needs to answer a question that spans 2 data types: what were first quarter sales in the Northeast, and what are customers complaining about in support tickets. The sales data lives in Unity catalog tables. The support tickets are PDFs in a Unity catalog volume. Which architecture is appropriate? A. A single RAG responses agent that retrieves over both the sales tables and the PDFs. B. A single Genie space configured to ingest both the sales tables and the PDFs. C. A supervisor agent that routes structured questions to a Genie agent and unstructured questions to ARAG responses agent. Or D. A LangChain agent executor with both data sources passed as Python dictionaries. Think it through. The answer is C. Genie Spaces only handle structured Unity catalog tables. They cannot ingest PDFs or volumes. RAG agents handle the unstructured side. The supervisor pattern routes structured questions to a Genie agent and unstructured questions to ARAG responses agent, then merges both into one grounded answer. Question 4. Which code snippet is the canonical LCEL retrieval chain shape on Databricks? Option A. Chain equals retriever pipe str output parser pipe chat Databricks pipe prompt. Option B. Chain equals a dict with context as retriever pipe format docs and question as runnable pass-through. Then pipe prompt pipe chat Databricks pipe str output parser. Option C. Chain equals chat Databricks.invoke applied to retriever.get relevant documents. or D. Chain equals DatabricksVectorSearch.queryPipe parse, pause and pick. The answer is B. The canonical shape is a dictionary that prepares prompt variables, piped into the prompt template, piped into ChatDatabricks, piped into the output parser. Option A places the parser before the model, which is the classic wrong shape. Options C and D abandon the pipe-composed runnable pattern entirely. Question 5. Let's test a concept from an earlier episode. DataDino selected a standard vector search endpoint with hybrid search and a built-in cross-encoder re-ranker for the fossil chatbot. Their German partners have a contractual end-to-end latency budget under 200 milliseconds. Why was storage optimized ruled out? A. Storage optimized does not support delta sync from the fossil chunks table. B. Storage optimized cannot be used with managed embeddings. C. Storage optimized does not support hybrid search at the index level. Or D. Storage optimized has a higher query latency floor than standard endpoints, exceeding the contractual budget. Think back to episode 8. The answer is D. Storage optimized endpoints trade latency for scale. They decouple storage from compute and carry a higher query latency floor than standard endpoints. DataDino's contractual budget of under 200 milliseconds is incompatible with that higher floor, regardless of any other capability. That's why the standard endpoint won the call. That's it for the Mosaic AI Agent Framework. Production-ready chains and agents on Databricks. Drop a like if this clarified things. Subscribe so you don't miss the rest of the Databricks GenAI Engineer Cert, and I'll catch you in the next video.